Yeah, welcome you all for another presentation on feedbacks in amplifiers. Feedback in amplifiers. Basically, this is a very important topic from your electronic devices and circuits subject. So, if you recall our previous presentation, there we have seen what is a feedback, why feedback is required, and what are the various topologies of feedback. And even we have covered in the last presentation the first two topologies. Basically, I will recall again. Based on the feedback we will provide in the amplifier circuit, the network or the feedback topologies are: the first one is, we have seen that voltage shunt, feedback topology, right? Voltage shunt feedback topology. And the next one is voltage series feedback topology, right? And then the third one is current. The third one is current series feedback topology. And then the last one is current shunt. The last one is current shunt. Current shunt feedback topologies. So these are the four various categories of the feedback topologies, right? So this is based on the feedback we provide in the amplifier circuit. That circuit is differentiated into these categories, four categories actually, right? And again, the basic circuit we have seen in the previous presentation, that say for example there is a amplifier circuit, and after amplifier circuit we have a sampler circuit, and to the left side of that amplifier circuit we will have a mixer circuit, right? So the amplifier is the middle part actually. To the right side of that amplifier we have a sampler, to the left side of this amplifier you have a mixer here. So the sampler circuit will samples. Okay, here the sampling parameter, or as we have seen in previous presentation, that is either voltage or otherwise current. Basically the outputs are, therefore that output which we are getting at the output of the amplifier circuit, that particular parameter, either voltage or current, whatever it is, if that output parameter is voltage, then that voltage is fed back through this feedback network to the mixer circuit. So how this output voltage is given to the mixer through this feedback? Is it in shunt connection or is it in series connection? The shunt connection also called as the parallel connection, right? The shunt connection also called as the parallel connection, right? Therefore, so in the last presentation we have seen the first two categories actually, right? So voltage shunt feedback and voltage series also we have seen in the last presentation, and today's presentation I would like to cover the rest two categories, that is current series and then current shunt feedback topologies. Let us see how basically the input and then output impedances are varies with the effect of this feedback. Let us recall the simple circuit as we have seen in the last presentation, that this is your amplifier circuit. This is your amplifier circuit basically. This is your amplifier circuit, and at the output of the amplifier circuit you will have a sampler circuit, right? This is what your sampler circuit, and then this is your output basically. You can, maybe you have some load resistance that you can call as some RL, load resistance. And to this left side of this amplifier circuit, what you will have, this is a mixer circuit actually. This is what? Mixer circuit. This is called mixer circuit actually. right? So for this you have the input. This is your input actually, and here you have your feedback network. This is your feedback network. This is your feedback network, and the gain of the amplifier is A. A is the gain of the amplifier, and for feedback network the gain is beta, is denoted by beta, and it is like a two-port network basically. On both sides you will have this. Now this is, let us assume that it is a current series. Let us assume that it is a current series feedback. Current series feedback amplifier circuit. Amplifier circuit. Okay, let us assume that it is a current series feedback amplifier circuit or current series topology, feedback topology. Now, so here current series, in this particular current series, so the first word is current actually, means that this current, in current series sentence or word, the current, this current indicates the output quantity, and this particular output quantity, how you are connecting back, feeding back to the mixer, is called series actually. So this series word correspondence to the input side, means it corresponds to the mixer, how that output parameter is fed back to the mixer, is it series or parallel, like that. So this series corresponds to the mixer, whereas this particular current is correspondence to the output, and basically that is with respect to the sampler, right? In current series, obviously your parameter is current only, means at the output you will have your current. So how we will have the current? In order to get the current at the sampler, your connection must be in this fashion. Let us see. Your current must be in this fashion, means like this. This is what the connection. So with this connection you will have the current actually. So you will have the current I0, and it flows like this through this terminal and through load resistor, through this, and then this current, it flows through the feedback network. The flow of current is like this. Clear? It goes like this. This is the flow of current actually. So in this way, this is connection. This connection is called as the series connection. It is not shunt connection. It is not parallel connection. It is a series connection. So what I want to convey you is that, so in order to get the current at the output of the amplifier circuit, means at the sampler circuit, if you want the current, you must give your connection in this way, means series connection you should give. So with the series connection, you will have your output parameter as current. Now this is what the current means. So at the output now your quantity is current. Now this current you must give through this feedback network to this mixer again here. So there are the two combinations again. It is current series, means that what current already I have got the current here because of the series connection. So that current I am feeding back through this feedback network, and I am giving to this mixer circuit. How? Series connection. Series connection is nothing but same as this connection only, means that you see here the same connection like what you have at the, this is what the series connection. This, however, this will be like this only, right? So what is this connection? Basically it is a series connection. As the name itself suggests as current series, therefore at the input also you must have your series connection, like whatever you had the output, same connection you should give here. Therefore it is called a series connection. This is also called as series connection. Current series also called as series connection, means your connection at the output is series connection. That's because of the series connection you will get output as current, and that you are feeding back through this feedback network to the mixer in a series connection. This is what current series. That is why it is called a current series feedback. Current series, right? This is what the basic circuit diagram for the current series feedback amplifier. Now what happens to the input impedance? What happens to the input impedance Ri? What happens to the output impedance because of this sampler? What happens to the output impedance here? R naught. R naught basically. Right? What happens to the R naught? Output impedance. R naught is the output impedance, whereas Ri is the input impedance. So because of this series connection, as I already explained you in the last presentation, that because of the series connection, either it could be at the output side or otherwise it could be either at input side, wherever it may be. Because of the series connection, the corresponding impedance will be increased. Therefore, so if you see at the output, nothing but at the sampler, it is a series connection. Because of the series connection, your R naught will be increased. Your R naught will be increased actually. This will be increased, right? Increased. So ideally speaking, your R naught is equal to infinite. Your R naught output impedance is equal to infinite here in current series. Similarly, what happens to the input impedance? Again, what is the connection here? It is a series connection. Because of series connection, again here your Ri is also input impedance also increased. It is increased. Means ideally speaking, your Ri is also infinite. Your Ri is also infinite. Therefore, in current series feedback amplifier, current series, so it is a series or otherwise current series. So in order to get the current, connection must be series. Therefore, this is also called series connection. So both are the series. In the connection at the output is series, and you are giving again as a series connection at the input. Both will be series. Because of the series connections, your both input output impedances will be increased. Ideally speaking, both are infinite. Ri is infinite, R naught is also infinite. That is what current series feedback amplifier, right? And let us, I think you are getting, I hope that you are getting. Now coming to the next class, next case otherwise, that is current shunt. The next one is current shunt. So I remain the current as it is, and now I will just change that the current shunt. Current shunt. What is current shunt? So current shunt is nothing but, again, this current corresponds to your output. So in order to get current as output, your connection must be the same, series connection only. I will not change the connection because I must get current as output. Therefore, connection must be in a series connection. This connection must be like this only. With this connection only, you will get output as current only. You will get current as output because of this connection. I will not change this connection. I will retain as it is. Now this current output, I am feeding back to this feedback network, and in the mixer circuit, how shunt connection. You must give a shunt connection. What is a shunt connection? You know, that is looks like this. Shunt connection is nothing but, let us say something like this. So this connection you will give here, okay, and this particular, the second line, the second terminal, you just connect to the first one. This is what the shunt connection means. If you connect like this, this is called the shunt connection. Clear? This is called the shunt connection. Therefore, current shunt means the output current should be connected in shunt connection in the input mixer. That is the meaning of it actually. So now at the output, what is the type of connection? Series connection. What is the type of connection at input? Shunt connection. Now tell me, because of the series connection, what happens to your R naught? R naught, because of the series connection, your R naught will be increases, and ideally it is infinite only, no doubt at all. Now coming back to the input side, it is a shunt connection here in current shunt. So this is the shunt connection. Therefore, because of the shunt connection, input impedance instead of increasing, it will decreases. Remember that. Because of the shunt connection, the impedance will be decreases. It is decreases. Ideally speaking, how much? Decreases means ideal value is 0. That is what the meaning of it. So ideal value is 0. Therefore, for current shunt feedback amplifier, so your output impedance will increases as well as your input impedance will be 0. So this is the fourth category actually. Likewise, these are the four classifications of the feedback topologies. So remember that these values, and again I will explain you these in another way otherwise. These four topologies, whatever we have seen just now, they also named with different names actually. Let us see those things. So far we have seen, what we have seen, tell me. The first one is voltage series. The first one is voltage series or voltage shunt, no problem. Voltage series feedback. Voltage series feedback. What is the second one? It is voltage shunt. It is voltage shunt feedback. Right? What is the third one? It is current series. It is current series feedback. What is the fourth one? Current shunt. It is a current shunt feedback. So here one important point is there to notice is that, remember that voltage series nothing but, voltage series is nothing but actually the output is in voltage series. Remember that in voltage series the output parameter is voltage only. Okay, in both these cases. So here is an amplifier circuit basically. It is a amplifier circuit basically. It is a amplifier circuit basically, and this is what your output, this is what your input, right? This is what your input terminal of the amplifier, input side, otherwise this is what your output basically, right? This is the amplifier circuit. So in voltage series as well as voltage shunt, your output is voltage only, V0 is your output, and V normally Vi is input, let us say. So in voltage series, right, voltage series. So in voltage series your output is voltage, clear? Your output is voltage. Okay, what is your input? You are giving series actually. Okay, you are giving that voltage, you are giving back in a series connection here. So because of the series connection, so you are giving as a series connection here. See, because of the series connection, what you will get, you know, what you will get? So you will get I as input. I as input. Therefore, what is output here? It is a voltage basically, and your input is current actually. In this case, in voltage series, your output is voltage. What is your input? It is a, because of series you will get current actually, current. Therefore, how you can write from the Ohm's law? V is equal to I into R. Or otherwise, if you take the ratio V by I, means output V0, input II, let us say. V0 by II means output voltage, input current, is it not? If you take the ratio, it is called actually R, means it is called, basically it is called trans resistance amplifier. This is called trans resistance amplifier. Trans resistance amplifier, clear? Trans resistance amplifier circuit. So remember that in trans resistance amplifier is nothing but, trans resistance is nothing but R only, resistance is nothing but R only. What is R actually? R is equal to V by I, that you must remember. So R is equal to V by I. Therefore, what is your V? V corresponds to output voltage. I corresponds to I, input. Therefore, output V0. This V corresponds to output, I corresponds to input. Therefore, voltage by current ratio you must take. Output voltage, because of the voltage, what you should get? Shunt connection. Therefore, your output impedance will be decreased there. And what is input here? Current. Current means your connection must be series, means input impedance will be increased. Like that. Therefore, they will ask you in gate examination for trans resistance amplifier, what are the values of output impedance and output output impedance and input impedance, like that they will ask you. Then you must remember that what is a trans resistance. Immediately you must note down this from the Ohm's law. R is equal to V by I. R is equal to V by I, where V by I numerator corresponds to output, means output voltage, denominator corresponds to input side, that is current. Therefore, output voltage, input current, V by I. So the output is voltage. How we are getting? Because of shunt connection. In order to get the series connection. So that is a shunt connection, this is series connection. Because of shunt, voltage will be output impedance will be decreased, and because of series, it will be increased, like that. Therefore, voltage series feedback is nothing but your trans resistance amplifier circuit. That is one important point. Similarly, tell me, voltage shunt amplifier. What is the name for voltage shunt? Again, voltage shunt, let us see. In voltage shunt amplifier, again the diagram is same. Again here voltage is nothing but this voltage corresponds to output. Means again voltage, so that voltage we are giving back to the mixer as again in shunt connection, because of you are giving here shunt connection. Because of the shunt connection, what you will get actually? Voltage again, means voltage again. Because of the shunt connection, you will get voltage, means here in the second case you will get voltage again because of the shunt connection. That voltage you can call it as a input voltage, Vi. Okay, so voltage shunt. So in voltage shunt amplifier, your output is voltage. That voltage you are giving as a shunt connection. Because of shunt you will get voltage again. Because of the shunt connection you will get voltage. Therefore, in this case, both input and output parameters are voltages only. Now that take the ratio, it is the ratio nothing but what is this? V0 by Vi. Clear? What is the ratio? Output by input. So it is V0 by Vi. What is this? It is gain. It is called gain and voltage gain. If you take the ratio output voltage by input voltage, that is V0 by Vi, nothing but it is called as gain, nothing but voltage gain. As the ratio is of voltages, therefore it is called voltage gain. Therefore, this amplifier is called as, what is this? Voltage amplifier. This is called voltage amplifier. This is called voltage amplifier circuit. What is the first one? Trans resistance amplifier. The second one is called as voltage amplifier simply. In voltage amplifier, your V0 is proportional to Vi. Remember that. Your V0, output V0 is proportional to input voltage Vi. So output voltage V0 is proportional to Vi. Right? So here if you take the ratio V0 by Vi, nothing but voltage gain. Right? Likewise. So coming to the third one, current series feedback. So in current series feedback, in the same way, now in current series as well as in current shunt, in these two cases, what is your output? Current is the output. Therefore, let us say here again amplifier circuit only. This is amplifier circuit only, no problem. You can write amplifier circuit only. It is amplifier circuit. Now in this case, in the third and fourth, the remaining 3 and 4 means current series and current shunt feedback cases, your output is current. Therefore, your output is current now, means I0. I0 means in order to get I0, how the connection must be? Series connection only. So your connection must be series. So this output current, how you are giving? Series again for this, for the third one. So output is current, you are giving back to as a series. So because of the series connection, what you will get? Current. Because of series you will get current, means what is your what is the parameter that you need to, so means that I input current. So in this case, in current series, now you take the ratio I0 by II. I0 by II. If you take the ratio of output by input, that is nothing but I0 output current by input current II. Again it is current ratio, it is a gain of current A suffix I. This is called ratio of the current. Therefore, it is called gain, current gain A suffix I. That's why this is called as current amplifier circuit. This is called current amplifier. So in current amplifier circuit, your output current I0 is proportional to II basically. That is the relation between those two parameters. So current series is nothing but it is a current amplifier. Voltage shunt is nothing but it is a voltage amplifier. Voltage series is nothing but it is a trans resistance amplifier. Right? And similarly, in the same way, come to the fourth category, current shunt feedback. Current shunt. Again, in this last one, current shunt, what is the output parameter? Current only, means output is I0 only. Now, This you are feeding back through in a which connection? Shunt connection. Because of the shunt connection, what you will get? Voltage. Voltage you will get, because of the shunt you will get voltage. Means as it is correspondence to input side, you will write V suffix I. Therefore, now take the ratio I naught by Vi, means output current, input voltage. Clear? Output current. So it is nothing but I naught by Vi, means at the output you are considering as current as output parameter, means I naught, and at the input we are considering input voltage as input parameter. It is I by V. This is nothing but simply, it is reverse of your resistance actually. I by V, let us see. I by V here. R is equal to V by I. This is something I by V. It is nothing but 1 by R. Therefore, reverse of resistance, this is called conductance. Therefore, G, it is called transconductance amplifier. Therefore, your current shunt feedback is called as transconductance amplifier. Transconductance 1 by R. Therefore, in transconductance amplifier, your I naught means the output current is proportional to input voltage. In this case, your output current is proportional to input voltage. Therefore, these are the 4 topologies, and for these 4 topologies, we have 4 different names. This is the trans resistance amplifier. This is the voltage amplifier. This is the current amplifier. This is the transconductance amplifier. Right? And similarly, these are the important points that I want to convey you. And one more thing is that one important parameter is that before I going to complete today's presentation, just I want to give you one more important point to note down here. Just I am telling you repeatedly that the input impedance will be increases and decreases. Similarly, the output impedance will be increases, decreases. Right? Okay. Ideal values we have seen, but when it comes to practical, how the input impedance Ri and then R naught, Ri and then R naught, how decreases means Ri is equal to input impedance without feedback, let us say, or some with Ri is initial feedback, and because of the series or shunt connection, whatever it is, or if because of the series connection, if it increases, let us say, then how much it will increase, Ri plus 1 plus A times beta times it will increases. Remember this. Because of the series connection, the impedance will increases. Because of the series connection. How much it will increase? It increases Ri times 1 plus A beta. Now you can call this as the newly increased impedance as R suffix IF. So input impedance with feedback. So with the feedback, let us say it is a series. Because of the series connection, the input impedance with feedback will increases by this factor actually. Actual input plus multiplied by 1 plus A beta times. Similarly, say for example, if the RIF is equal to, if it decreases, then how much it will decrease? Ri by 1 plus A beta times it will decrease. I am telling you that in depending on the 4 topologies, depending on the feedback we will provide in the circuit, your Ri will be decreased and sometimes it will be increased. If it decreased, how much it will decrease? With the feedback, your input impedance will decrease by this Ri by 1 plus A beta times. Decreasing means, simply remember, actual Ri is nothing but this is the input impedance without feedback. Ri by 1 plus A beta times. If it increases, you just multiply, that's it. You must multiply the actual input impedance with 1 plus A beta times. Similarly, the same case for R naught also. R naught F means the output impedance with feedback is equal to R naught plus 1 plus A beta. Means if at the output the connection is series, then output impedance with feedback will increases by this parameter, and say for example, if it is a shunt connection, your output impedance with feedback will decreases by R naught by 1 plus A beta times. These are the practical values. Actually. So 1 plus A beta times will be decreased and 1 plus A beta times multiplied. Increased means multiplied by 1 plus A beta. Remember that. Multiplied by this factor with that actual input impedance without feedback. whatever it is, either it could be input impedance or otherwise it could be output impedance. Very, very important topic, very important topic, right? I hope that you understood well, right? And thank you for watching this, and we'll meet with some more important topics in our subsequent presentations, right? Have a beautiful day.